All right, welcome to The Explainer. Today, we are diving deep into the world of quantum computing. And look, forget all the science fiction stuff you think you know. We're talking about what's happening today, right now, in 2025, and more importantly, how you can actually get in on the action.
This says it all, doesn't it? What used to feel like a distant dream, something whispered about in academic papers, is now very, very real. It's tangible. The future we've all been hearing about for so long, well, it's finally starting to knock on the door.
And get this isn't a spectator sport. Right now, the machines are humming, the ideas are sparking, and there's basically an open invitation for everyone, developers, researchers, even just the super curious, to step up and become a part of it.
Okay, first up, meet the quantum ensemble. So who are the big players actually building these revolutionary machines? You might picture some kind of cutthroat race to the finish line, but the reality is, well, it's more like a jazz band, with every member bringing their own unique sound to the stage.
And I just love this analogy because it's so perfect for where we are right now. There's no single right way to build a quantum computer. Not yet, anyway. Instead, every company has its own unique flair, its own improvisational style. And all that experimentation is exactly what's pushing the entire field forward.
So let's take a look at the band members. You've got the heavy hitters, IBM and Google, using these things called superconducting circuits. They're kind of the rhythm section, really pushing for scale and raw speed. But then you have a completely different approach from a company like IonQ. They're using trapped ions. We're talking literal individual atoms held in place by lasers. Talk about precision. It's like hitting a perfectly clear note every single time. Meanwhile, Microsoft is making this really bold experimental bet on something called topological qubits. The hope is that they'll be naturally stable, which if they pull it off would be a total game changer. And then there's D-Wave. They're not trying to be the whole orchestra. They're a specialist. They are absolutely laser-focused on one thing, using quantum annealing to solve incredibly complex optimization problems. And they're doing it today.
All right, next section, your cloud access pass. So, we know these incredible, complex, super-sensitive machines exist, but they're tucked away in highly specialized labs. So, how in the world do you get your hands on one? Well, the answer is actually a lot simpler than you might think.
This is the crucial question, isn't it? You don't need a PhD in physics or a multi-million-dollar lab to start experimenting. The keys to the quantum kingdom are, believe it or not, in the cloud.
And this is the part that is just incredible. It has become so accessible. We're talking about the big cloud providers you already know, AWS, Azure, Google, and IBM. They all now offer direct access to real quantum hardware. And you do it using familiar Python-based toolkits like Qiskit or Cirq. So yeah, you can literally write code on your laptop from your bedroom and run it on an actual quantum computer. How cool is that?
And you can really start this today. Think of it as your first jam session. Step 1. Go sign up for the free tiers these providers offer. Step 2. Start exploring. They have tons of sample circuits you can play with to see the principles in action. And then, Step 3, when you're ready to move from a simple tune to a full composition, there are grants and paid tiers to help you tackle much bigger projects.
Okay, so let's look at some demos in the wild. This all sounds amazing, but what is this technology actually doing? What's it good for? Let's check out some of the early but very real applications that are already out there.
This quote just nails it. The applications we're seeing today, yeah, they might be a little rough around the edges, but the magic is undeniable. You can just feel the potential. It's like hearing the first few notes of something that you know is going to be truly transformative.
And the performance has already started. In pharmaceuticals, IBM and Moderna are using quantum computers to model mRNA molecules, which could totally speed up drug discovery. In finance, companies are using D-Waves annealers to optimize incredibly complex investment portfolios. And in an area that's critical for all of us, teams are already testing the next generation of encryption to secure our data in a post-quantum world.
And the list just keeps going. Google is helping predict the properties of new materials, which could lead to better batteries. D-Wave is optimizing delivery routes to save time and fuel. Atom computing is even working on how to better manage national energy grids. These aren't just theoretical problems. These are huge, real-world challenges being tackled by quantum today.
So, we've seen the players, we know how to access the stage, and we've heard the first few songs. Now it's time to talk about how you can join the ensemble. It's time to play your part.
If you're an individual developer, a student, or just a curious learner, the path forward is pretty clear. First, learn the languages. Python-based frameworks like Qiskit and Cirq, the most common entry points. Second, simulate before you fly. Use the amazing simulators out there to build and test virtual circuits right on your own machine. And third, and this is a big one, join the chorus. Get involved in communities, find hackathons. That's where the real collaboration and learning happens.
And for organizations, the strategy is just as clear. Start now, but start with small, well-defined proof-of-concept projects. Then mix your teams. This is so important. You need your domain specialists working right alongside programmers and scientists. And most importantly, start planning ahead. Build quantum knowledge into your strategic roadmap today because the changes, especially in areas like cryptography, are coming sooner than you might think.
And that really brings us to the whole point. We are at this absolutely unique moment in history. The foundations have been laid, the instruments are tuned, but the masterpiece has not been written yet. The score is open.
The stage is set, and the ensemble is waiting. The only question left is, what part will you play?